Welcome. We have seen vectors, at least their geometric definitions, right? We know a vector consists of a magnitude and a direction, and now we want to look at a vector from more of an algebraic perspective, because everything in math, we want to be able to work in different forms with it, right? Geometry and algebra are kind of our two go-tos, so let's make sure that we can work with this thing algebraically. So now we know that a vector has an initial point, let's call it P, and it goes to a terminal point Q, right? And now the only thing that we're going to add to kind of put this into an algebraic context is coordinates. So let's say that this ends at x2, y2. And then this end begins at some x1, y1 point. And just for simplicity, let's assume we're in the first quadrant. It doesn't need to be, but it just makes things easier. So we have x1 here, we have x2 there, this is y1, and this would be y2, okay? And so then vector v is this lovely little vector here, okay? And now how can we represent this thing algebraically? I want to be able to say, v is equal to something, and then have that expressed in more of an algebraic manner. Well, algebraically, since we're in the coordinate plane, we should probably talk about, an x and a y, right? And a vector, at the end of the day, remember, it is just a magnitude and direction. We don't actually care where we begin and where we end. And so when we talk about vectors, we've talked about them before as a horizontal component and a vertical component. Okay, and that's actually the notation we're going to use, is this angle bracket notation, and then we would list the horizontal motion and vertical motion. Okay, well, how much is the horizontal motion? Okay, well, that would be this part as we extend from left to right from x, so we would end at x2 and begin at x1. And so if I'm looking at representing this thing algebraically, I could say that the horizontal component is x2 minus x1. Oh, okay. And then the vertical component would be here, like how far I rise. Okay, notice this is kind of looking and smelling a lot like a slope of a line, and it should. But for us right now, the vertical component is going to be the y2 minus y1, the change in the y's. Okay, and the only specific thing here when we're working with a vector is that it needs to be final minus initial, otherwise we're going the wrong way. Okay, so just make sure that we're doing final minus initial for each of these to determine the component form of the vector. Okay, and going forward, we generally just say that a vector is, an a comma b value. Okay, a horizontal motion or a horizontal component and a vertical component. Okay, so that's fine. And now we have some way to talk about a vector algebraically. Let's see an example. Okay, so we have vector v, initial point, terminal point. Okay, fine. And maybe let's just sketch it so we can see this on the coordinate plane. Okay, so we're at initial point is -4 and then +5, so right about there. And then terminal point -1, -3, so down here. Okay, and I'm just going to draw it so I can see it more easily. So this is vector v. Okay, it says find component form. Oh, okay, so vector v's component form is going to be, x2 minus x1, okay, y2 minus y1. And so then I get, let's see, this will be -1 minus a -4, comma, -3 minus 5. Okay, so then I think if I do the calculation, I get 3, -8. Okay, so, and actually I can see that, so I go 3 to the right horizontally, and then 8 down. Oh, okay, that's fine. So I did A. Okay, now part B. Part B introduces a specific type of language that we are going to see frequently, standard position. Okay, so it just means that a standard position, we draw the vector so that it's its initial point is at the origin. So from the origin, I would say let's draw vector v. Okay, so I would have its initial point there, and then I I go according to this motion. So it says go 3 to the right, so 1, 2, 3, and then 8 down to get to my terminal point. Okay, so there's another version of v. And again, vectors are just magnitudes and directions, so you can actually put them wherever you want in space, okay, as long as they're, same direction and magnitude. All right, and then last problem says sketch W with that as initial point that. Okay, so 2 and then 3. Okay, there's the initial point, and then go from here, go 3, 8 to 3, and then that's 3, 6, 8. And there's W. Oh, W seems very familiar. It should. It should. And in fact, I would actually say W and V are equal. Okay, equal vectors have same components, and if we looked at the components, right, 3, 3, 8, or negative 8, negative 8, they have the same components. Okay, they could also have the same magnitude and direction, and that's fine too. The last thing that we want to be aware of when we're working with algebra vectors is that all of our expected properties carry forward. So if I'm looking at this example here, and I want to find minus 4s, okay, this is literally just minus 4 and then times the vector s, which I know to be 12, and then minus 7, okay? And then in this case, the scalar multiple goes into each component. Before with the geometry, we said that we would just make it 4 times as long in the opposite direction. That's true. In component form, though, we would see that this would be minus 48, so negative 4 times 12, and then minus 4 times negative 7 would be positive 28. Okay? R plus S literally means we take negative 3, comma 6, R, plus, and then S, 12, minus 7. Okay? And then to add these things, you add the respective components. Okay? So I am going to say that the result is going to be, let's see, so I would add the horizontals, so negative 3 plus 12 is 9. And then the horizontal, 6 plus negative 7 is minus 1. Okay, and those would be my answers for the first two. I want you to pause the video and try the last two, and resume the video when you're ready to see the solutions. And here are my answers for the last two. I did a little bit more work than you maybe need to, but again, I wanted just to make sure that this minus went into both components, and then I changed the sign in between to addition. Same thing happens in the second one where I distributed into each one first. Again, I distributed minus 2, which would make it positive, and then make sure to add the respective components to get your answer. With that, we know how to work with vectors algebraically now, right? Component form, we can just say that to get the component form, if we know the initial and terminal, you would just subtract terminal from, or initial from terminal, or do terminal minus initial, right? And get it in component form. So A and B represents the horizontal and vertical components. We know about standard position, right? Just having the initial point at the origin and then moving according to the vector based on its components, and then how to add and subtract vectors algebraically.